The concept of net zero energy is becoming more and more vital in building and construction, and is an essential feature that must be catered for in the design. Located adjacent to Innovation Way, Ferry Meadow, the single-storey, two-bedroom residential property incorporates a strong net zero energy approach whilst still ensuring comfortable living for the occupant. The building has been designed for a three-person household in which both the adults are to be considered scholars. One of the adults is assumed to work from home and care for the child, whilst the other works at the University of Wollongong and visits the Innovation Campus frequently. The initial house will be located at the front of the proposed plot with access from Innovation Way. As seen in the figure, more lots can be subdivided for future developments and infrastructure. The existing residential properties have minimal effect on the proposed structure as the site boundary is delineated by trees and a fence. The initial planning began with a bubble diagram in the early stages of the semester and was used to explore spatial relationships and the layout of a house. As weeks progressed, an initial floor plan was developed in which highlighted various issues. The first floor plan accounted for the outdoor space within the 100 square metre limit, as well as having a poor layout. The week 6 floor plan significantly improved on this. However, privacy and orientation were not considered and needed further improvement. With each iteration, various feedback was used to improve the floor plan, with various aspects remaining in the final design that were incorporated in earlier sketches. Very early sketches were made with little knowledge of occupant or net zero energy design. The first few weeks of the elevation development were heavily focused on double-storey property. However, once the occupant profile was selected, the design moved to a single story to accommodate for a family with a young child. As seen in the sketches, the house had various iterations in which a final design was inspired by various research and properties around Wollongong. The developed floor plan shows an accumulation of work and research throughout the semester. The design is heavily focused on implementing a net zero energy approach while still ensuring comfortable and private living for the occupants. A thermal mass wall will be used not only to improve thermal performance, but to also delineate the private spaces from the open living plan, as well as providing extra storage. The alfresco design holds true to the Australian lifestyle and allows for connectivity throughout the house. The occupant profile inspired many design aspects of the house, including the study hidden away in the bedroom and the outdoor private area for the adults. The 3 wet areas have all been placed within close proximity to allow for improved efficiency when moving water. Tractile solar panels will be split evenly on both sides of the roof to ensure enough energy is supplied in both the morning and the evening. Studies show an average 3-person household uses 13.7 kilowatt hours per day, in which 50 tractile solar panels will generate 16.8. Below the tractile solar panels sits a weatherproof membrane followed by the earth wool insulation. Lastly, a layer of plywood binds the roof together and results in an R value of 5.62, which is much higher than the required 4.8 in New South Wales. The wall is a significant factor to a structure's thermal performance. WeatherTech's Self-Lock V-Groove has been chosen for the exterior finish and is followed by various layers that improve the house's thermal performance and results in an R value of 4.37. A suspended slab has been chosen for the structure in which incorporates fly ash and blast furnace slag. The slab will be insulated by earth wool and uses inbuilt heating and cooling system to provide an extra thermal comfort. As well as this, a global vapor membrane will encompass the entire structure to further the thermal performance. Automated louvers on the western side will be connected to the property's centralized computer and will provide ventilation if a certain temperature is hit. These louvers will open up automatically and allow air to circulate inside the building, with the hot, stale air rising and exiting through the window at the top of the raked roof. As mentioned previously, a thermal mass facade will be incorporated within the property. During the winter, the low angle of the sun will allow light to penetrate and hit the wall, subsequently heating the structure. Whilst adversely, in summer, the eaves will prevent the sun from hitting the wall and be used to cool the structure. The adjacent wet areas will use electronic thermal mixing valves to reduce excessive water consumption. Inspired by the desert rose, an air-to-water heat pump will be used to utilise the humid air around Wollongong. This will also be stored in a phase-change material tank that can reduce the peak loads of the heat pump. To accompany this, an underground water tank will be used to capture stormwater from the roof, whilst the water captured by the tractile solar panels will be used as hot water or to heat the concrete flooring if necessary. All these aspects will be connected to the centralized computer and allow for superior energy efficiency and a pleasant living experience. Thank you.